Hi, hi. Hello everyone, this is Ari from pantechelearning. So is my voice is clear guys? Is my display is visible? Anyone in the chat box? Then we will get in the session. Okay. So Kageshri, good evening. Sapna, good evening. Good evening guys, good evening all. So guys, we will get in the session before that. So thanks, I'm fine Fatima. How's about you? So guys, is my voice is clear? Prem, good evening. Good evening all. Sudagar, good evening. Sneha, good evening. Varsha Venugopal. Okay, is this my voice clear now? Okay. Manisha, good evening. Good evening. Okay, okay, Fatima. Okay. Okay, we will get into the session within 2 minutes. Okay, we will wait for the students to join. Okay, participants to join. Guys, is my voice now clear? Are you still now hearing some echoes? Is it not clear? Okay, thanks for the workshop. So we can get into the class. Okay. So today we are going to get into the concept in DAC. In that we are going to use the function is direct memory access. So DMA. So first we have to know what is the use of the DMA. So consider I'm reading a value from the temperature sensor. Okay. So I'm going to read a value from the temperature sensor and it is going to convert my analog value to digital value using the ADC and it is going to show me out. Okay. So what is the use of DMA here? So if I want the values from starting to end, so I'm for let's consider a scenario. I'm going to measure the temperature for room temperature for 1. Okay. So I need a value from starting to end point. Okay. Okay. So next is so we have to save that value, right? So you have to store the value in the some of the place in memory. So here we will go with the DMA and when it comes to the without DMA means the data should be get updated after the loop. So when we use DMA means the value will be taken from the value from the ADC from peripheral ADC to it will get stored in the memory unit and the value should be referred from the memory unit only. It will take the value from the memory unit. Okay. So by this By this we can see the output at every time. Okay. So this is the use of a DMA. So today we have already seen how to configure the ADC. So we will use those ADC setups and we will implement the DMA in the ADC setup. Okay. So before we have to see some registers. So before getting into registers, what are the things we have to do? So what are the functions we are going to create? First is we are going to create this system clock. Then we are going to create as a ADC init function. Then we have to enable the ADC, right? So we have to create, we are going to create a ADC enable function. Then we will create a ADC disable function, and we will go with the. Then we have to start the ADC process. Right? For that, we have to. So next we have to start the ADC process. Then for that we will create a ADC function. Then we will get into the DMA, direct memory access. So we have to create a init function for the DMA, and we will create a function for DMA config. Okay. Okay. So we will elaborately see what are the things we are going to do. So in initialization of ADC, we have to enable the clock for ADC and GPU. We have to set the prescaler value in the CRR register. Then we have to enable the scan mode, and we have to set the resolution. It can be 12-bit or 10-bit or 8-bit. And we have to enable the continuous conversion, end of the conversion, and we have to say the data element. So we will use the data element in the right. Okay. Then we have to set the sampling time. Then we have to set the regular channel sequence. Okay. Then we have to set the motor register in the GPU. Then we will enable the DMA and continuous request. Okay. So, and the final thing we are going to do is we are going to select the sequential channel. So we are going to select the sequence of the channel to work. So I already explained in the ADC. So if I consider the temperature sensor with the channel 1 and the temperature sensor 2 with the channel 2 means I have to say to which channel to work first, which channel to calculate the first process. So by using this only we will say to which channel. If I want to read the first temperature value, temperature sensor 2's value means I will send the first channel to this sequence. Okay. So for this purpose. Okay. So next is, so guys, before going to the next topic, so you can now convert this internship into a masterclass. So it is a 1 month of internship on embedded systems. So the fees will be 1200. The discount is 509, and you can use the code ESMC1. Then you will get a internship fees of 691, guys. So lots of topics going to be added in the internship, and it's going to be in a detailed way. And use this opportunity, guys. Use this opportunity to upskill yourself. So what are the benefits of this? So you can have this 30 days of masterclass live session for recordings. For that you will get a wait. You will see the benefits. Okay. So you will have 30 days of live sessions recordings. It will be accessible for 90 days. Then you will get an hands-on practice on embedded projects. So you will develop lots of projects based on the embedded systems, based on the STM controller, and you will be able to get a 30 days of downloadable presentations. Okay. So next is we will have a main advantages. We will have a one-to-one mentor live session in every Saturday class. So already one class is over. So we are left with the 5 classes. So on coming Saturday there will be a second class for batch 2 and batch 1 peoples. So guys, before Friday, guys, register this to attend the Saturday's live session. Okay. Then from next Monday, the batch 3 will be getting started. Okay. So then what you will get? So you will get an internship confirmation letter after registering. So we will provide and we will also going to provide 2 e-certificates. One is for participation and another one is for course completion. Okay. So next. So the guys, this is the fees 1200 and the coupon is ESMC1 and the discount price is 509. So the discount fees will be finally rupees 691 only. So use this link for registering internship. The link will be provided in the chat box, guys. So don't miss this opportunity. So you can click this link and directly register in the internship. So I will give a time for it. So you can use this time to register for the internship. Okay, guys. Okay. So next we will get into the topic. Okay. So next function we are going to create is ADC enable. This will on the tune on my ADC. Then we will also create a ADC disable function. Then we have to start the ADC conversion. Okay. So for that we will create a start function. Then we will come to the DMA initialization. First, as well as we have to enable the clock for DMA. Then we have to set the direction for it. So when it comes to DMA, we can use three methods. One is we can transfer the data from peripheral to memory, memory to peripheral, or memory to memory. So we have to say the direction. So what is the direction we are going to use? ADC is a peripheral and we are going to save it in the memory unit, right? So we have to set the direction as peripheral to memory. So this will send my data from the peripheral to memory. Okay. Then we are going to set the circular mode, so it is going to be run repeatedly. Then we have to say the size of the data. What is the data we are going to get, and the size of the memory. So we are going to save the data, right? So we have to say the specify the memory size. Okay. Then we have to select the channel. Okay. Then before going to the next topic, guys, we are going to know about Panda. So our mission is to help the 10 million students to learn the technology in an easy way. So what are the things we are doing? So we are educational equipment manufacturers. So we are manufacturing lots of things, embedded projects, PCB projects, and FPGA projects, lots of things. And we are giving to the students and providing to the students, and we are providing knowledge. So we are providing internships, workshops, and masterclass like these things. So in the pantechelearning website, you can go and search in pantechelearning website. So there's going to be a new course launch for an embedded system engineer. So it will be a complete course from the beginner to advanced. So it is for the time of 3 months. So guys, that internship will be that program will be very much useful for your students to get upskilled. So after completing those 3 months of course, you can apply for the job or you can change your domain. So it will equip you as an embedded engineer. Okay. So what are the rest of things we are doing? So we have lots of lab related to the IoT, EV, AI innovations, autonomous vehicles, brain computer interfacing, data science lab, and we also have embedded design labs, PCB fabrications. So you can also get a PCB by giving a design or by asking some requirements. You can design your PCB on your own design. So and we also have an FPGA and DSP labs, and we have a microcontroller labs also. So where your product create projects and develop the lots of codes. And we have a power electronics and drivers labs, and finally we have a renewable energy design lab. So these are the labs and these are the solutions we are providing. So guys, you can visit this website and you can make use of it. So not for only for the students. So lots of things we are giving. So for the college, for the workers like this, we are giving lots of things. So you can approach the pantechelearning for getting any types of project. Okay. So these are the projects which we have given to some of the famous colleges. So these are development kits based on some controllers. So it will have all the things inside this controller to configure. Just you have to upload the code and you have to select the pins to make some configuration. Okay. So for product inquiry, you can email this, use this mail ID for product inquiry, sales@pantechmail.com, and you can use this to both the contact numbers for contacting. You can directly speak with us. So you can ask, you can raise the inquiries related to the products. Okay. So it is located in the Semanjeri, Chennai, near Microchip. Okay. So we are we have these labs, all these labs, so we can create whatever project is needed. Okay, we are already developing the advanced projects. So if you guys also needed to develop some projects, you can approach the pantechelearning. Okay. So what you will get? You will get an educational equipments, components and sensors, funded project support, technology. You can also get fund for the projects. Then you have technology transfer and fast prototyping, and we have an LMS support for kids. Okay. So you can have when you visit the pantechelearning website, you can see lots of videos. So that is what LMS support is. Okay. Okay. Now we will get into the class. Okay. So next is we are going to create a DMA configuration. To we have to send the size. You have to say the size, and we have to say where is the source. So I will set the ADC as the source, and we have to say the memory address where to store destination source. So we will we have to say the memory address, and finally we have to enable the DM. Okay. Okay. So the guys, we are hiring for the placements. So we will provide a technology and we will be arranging your placement for you guys. So for registering, the link is provided in the chat box, guys. You can use this to register. Okay. So you can join now for the placements. Okay. Okay. Now we will get into the we will develop the code for this. We will get into the code. So what is the take home back? So guys, this is based on your performance. It will be from ranging from minimum package of 4 LPA to what is the knowledge and what is the thing you have gained. Okay. So it is based on your performance. So we will now get into the topic. Okay. So we will open the cake. Go to the new project. So now we have to select the board we are using. Okay. So the census code. You have to do the census code and start. Now we will add the ADC. So what is the first thing we have to do? We have to include the startup file. So STM32. So the first thing we are going to create is we are going to create a system configuration. Okay. So void of so we have already created for the ADC in before class. So I will create this. So I will make a copy from the old ADC. Okay. Oh. So now we will get into the ADC init function. Okay. So for the system configuration, so guys you can refer the ADC video which is before 2 days. Okay. Now we will create a function for ADC init. So first thing what we have to do, we have to enable the ADC, right? You have to enable the clock for ADC. So go to the RCC register. In that we have to go to the so we are going to configure this ADC1. So as I have already reached you in the previous ADC class that it is in the ABB bus 2. Okay. Here now. So in this you can see we have an 8th bit as an ADC1. So we have to send logic to this logic 1 to the 8th bit in RCC ABB21 EN. Okay. CC. And left shift of 8. Okay. So the next thing what we have to do, we have to go to the So we have to see the channels, right? So we have a channel 0 in the PA of 0, and we have a channel 1 in the PA of 1 and channel 2 in the PA of 2. So we will use this PA of 1 and PA of 2. Okay. So we will use this. So you can see we have a channel 2 and 1. Okay. So this is in the GPA of port A. So then we have to enable the clock for GPIO. So go to the AHB1 bus, register ENR. So you can see we have it in the 0th pin, okay, 0th port, okay, push. Left shift of 0. So this will enable my clock. Okay. So this is going to enable the ADC1 clock. This is going to enable the GPIO A clock. Okay. Then we have to set the frequency, right? So what is the frequency we have used in the previous class? So system clock is going to give us an 8 megahertz of frequency for like APB 2 bus. So I am going to use it for, yeah, I am going to divide it by 2 and I am going to use this 4 megahertz. So for that, what is the register we have to go? We have to see is ADC of CCR. Okay. This we have a common control register. Okay. In this you can see we have an ADC prescaler here. So I am going to send the logic 0 to the this bit. Okay. So instead of that, we will send logic 1 to the 16th bit. So we will divide the 8 megahertz by 4. Then it will run in the 2 megahertz. Okay. Okay. For that, wait. So go to the ADC of CRR. In this, we will upshift the logic 1 to the 4th bit. Okay. Sorry, 16th bit. Okay. So ADC of CRR is equal to left shift of 16. So this will divide my clock by 4. So it's going to divide 8 by 8 divided by 4 is equal to 2 megahertz. So my ADC P square value is 2 megahertz. Okay. Okay. So next we have to enable the scan mode and set the resolution. Okay. So go to the So in this you can see we have a resolution bit as 24 and 25, and we have a scan mode in the 8th bit. Okay. So you can see you have a scan mode in the 8th bit. So you have to send logic 1 to the 8th bit, and we are going to use this 12 bit resolution. Okay. Now, so we will send logic 0 to the 24 and 25. Okay. So first you have to send the ADC of 1. So this will enable my scan mode. Then we have to say the resolution. Okay, we are going to use the ADC of 12 bit resolution. So F shift of 24 and 25. So this will set my resolution in 12 bit format. Okay. So next we have to enable the end of conversion and continuous conversion. Okay. So it is in the control register 2. You can see we have a data alignment EOC and CCS here. Okay. So we have to send logic 1 to the first bit, 10th bit, and logic 0 to the 11th bit. Okay. So we will send this. So it is in the CR2 and left shift off. So first is we have to continuous conversion. So next is end of conversion is in the 10th bit. Okay. So now we have enabled the CC and EOC. Okay. So next we have to say the alignment. Okay. So ADC of 1. Shift off 11. So this will make the alignment right. Okay. Right. We have selected the right alignment. Okay. So next thing we have to do is we have to say the sampling time. Okay. So we have to set the sampling time. So we are getting frequency is 4 megahertz. So we have to set the sampling time. For that, we have to go to the SMR prescaler. Go to so prescaler 1 has from 10 to 18 channels, and for the SMR prescaler 2 has a channel from 0 to 9. Okay. So now we have to send the value to the channel. So what are the channels we are using? We are using is first channel and second channel, right? So we have to send the logic to the 3 and 6. So we are I'm going to use this cycle of 3. Okay, it is the cycle of 3. So for roll bit, we are going to use the cycle 3. Okay. So ADC of 1. So I am going to left shift the 0. Okay. Three and 6. So now I have selected the sampling time for the my channel 1 and 2. Okay. Next is we have to say the number of channels we are going to use. So I am going to use this 2 channels. Okay. So for that we have to go to the SQR. SQR of 1. In this we have a dedicated bit is 20 to 23. Okay. So if I am using the 1 means I have to send 0 to the 20 bit. So I am going to use this 2 channels. So I have to send the logic 1 to the 20 bit. Okay. So I will send this ADC. On left shift of 20. So this is going to select me a 2 channels. Okay. So so 2 channels. Okay. So next thing what we have to do, we have to select the mode for the function. So for the pin. So we are going to what is the function we have to use for the pin? So we have to use the input mode. Okay. So go to the mode register. So we should not select the input mode, we have to select the analog mode. Okay. So then I have to what are the pins I am using is 1 and 2 because my channel 1 and 2 is in the first and second pin. So I have to send the set the analog mode in the this first and second pin. Okay. So then I will simply left shift the 3 to the second position and fourth position. So this will set my the GPA of A mode or okay. So 3 left shift off. So what are the questions? So you have to send to the 2 and 4. Okay. So 2, 4. So this will set my analog mode. Okay. So next we have to do is now it will comes to the new concept. So now we have to first thing we have to do is enable the DMA and we are going to give a continuous request. Okay. So for that you have to go to the ADC's control register 2. So in this we can see we have an 8th and 9th bit as an DMA mode enable and DMA requests are issued as long as the data are converted. So we have to send the logic 1 to the 9th and 8th bit. Okay. So now we will send it. So ADC of 1, CR of 2, 1 left shift of 8 and 1 left shift of 9. So this will enable my DMA mode and it will enable the continuous request. So next thing what we have to do, next thing is we have to select the sequence. Okay. So go to the registers. In that go to the SQR3. So in this you can see we have a channel from 1 to 6 channels. Okay. So we have to say the sequence. So in which sequence we have to calculate the values. So I'm going to use the channel 1 and 2. So I will left shift the 1 to the 0th bit and 2 to the 5th bit. Okay. So ADC of 1. Or 3. 1 left shift of 0. Okay. So next is we have to send the second channel to the 5th. So this we have settled the sequence. Okay. So sequence for this channel 1, comma 2. Okay. So now we have finished the init function. Okay. Then we have already created the start function, enable and disable. Okay. So I will make a copy of it. We have already developed this for the previous ADC class. So if you have any doubt means you can check those classes. Okay. So we will next get into the DMA init function. So the first thing we have to enable the clock for DMA. Okay. So go to the registers. So we have a DMA in the AHB1 bus. Okay. So go to the AHB1 EL0. So you can see we have a DMA enable clock in the 22nd bit. So we have to enable, we have to send logic to the 22nd bit. Okay. So before that, we have to know in which stream, in which DMA the ADC is connected. So we have a total of 14 channels, 14 streams, and 14 channels. So you can see in DMA1 we don't have ADC. So in DMA2 you can see we have an ADC1 in the channel 0 of stream 0. So we have to specify these things. Okay. So first we will enable the clock for so this will so we have to send the logic one to the 22nd bit. So this will enable the clock for the DMA. Okay. So what is the next thing we have to do? We have to say. So you can wait. I will show it in the data sheet. Okay. You can see here we can do these three operations. So peripheral to memory, memory to peripheral, memory to memory. So we have to set the direction. Okay. So for setting the direction, you have to go to the DMA first. In that you have to see the control register. Okay. So go to the so you have to go to the configuration register. Okay. So in this we have a dedicated bit for direction selection which is 6 and 7. So what I am going to do is now I am going to send the peripheral to data from the peripheral to memory. So I have to set logic 0 in this bit. Okay. So I will. So For this, we have to mention which DMA is. So DMA of 2. So in that, we have to set the stream. Which stream is the ADC one is controlled? It is controlled to the stream of 0. So in that, we have to select the control register. Okay. So I am going to send the. I will simply left shift the 3 to the 6th bit. So this will. Set my direction from peripheral to memory. Okay. So what is the next thing I have to do? I have to select the circular motion. Okay, circular mode. So I have to send the logic one to the 8th bit. And I also want to set the size and the memory size. I have to say the data size and the memory size. So it will be in the. So you can see we have a peripheral data size and we have a memory data size. So what is the thing we are going to use this? We are going to use the 16 bit. So I have to send the logic 1 to the 13th and logic 1 to the 11th bit. Okay. So we will configure this. So DMA of control register. So one left shift off. So one left shift one left shift of 8 will enable my circle. Okay. Then DMA of 2. Next in the control register, we have to send the logic to the logic 1 to the 11th bit to say the data size and logic 1 to the 13th bit to say the memory. Okay, memory size. So data and memory size. So we have given the data and memory size. Next, we have to select the channel. Okay. So for that, go to the control register. So in this, you can see the we have a 25th bit as a channel select. So what is the channel we are using? We are using the channel is channel 1 and 2. So we have to send the logic 1 to the 25th bit, and again we have to send the logic to the 25th bit. Okay. So you can see here we have a channel select from 25 to 27. Okay. So we will send the logic 1 to the first channel. So we will use the only one channel. Okay. EMA. And left shift off. In which bit I have to send it? I have sent to the 25th bit. So for channel selection. So 25th bit. Okay. Now we have selected the channel 1. Okay. So next is we are going to create this configuration function. Okay. So void of EMA config. Okay. So void. So inside the config, what are the parameters you are going to send this? First we will so first is we are going to send this source address. We have to say the source address. Okay. So source address. Yes. Next is we have to send the destination address. So yes. Okay. So next is we have to say the size. Okay. So for that. So these are the parameters you are going to send it. So for that, for saying the size, we have to configure in the go to the registers. We have to configure in the NDTR register. So go to the NDTR. And so in this, register, we have to send the size value. Okay. So we will send the size value here in NDTR register. So DMA of 2. In this, we have to do the NDTR is equal to size. So this will say my size. Next is DMA of stream of 0. So next I have to say the source address. So for source address, go to the peripheral address register. So we have to give the address to this peripheral one. Next we have to say the memory address. So we will use this register. Okay. So go to the source address of. So this is SRC address. So next is we are going to create this destination address. Okay. So for the DMA of 2. Of in this we are going to we have two memory addresses register. So this is this one memory address one is for double buffer. So we are going to use the double buffer. So we will use this memory address 0. Okay. So M0 AR. So this is equal to my address. So finally, what is the thing we have to do? We have to enable the DMA. So DMA of 2 0. In this control register, the enabled DMA will be in the control register. So it's equal to in the 0th bit. Okay. So on 0. So this will enable my DMA. Okay. So now we have created the function. So next we will create an unsigned of 16. In this I will create a RX of data. It will be the holding value. So now we will create the int main function. So int main of okay. So int main we have to first we have to do the system clock. Then we have to int the ADC in it. Then you have to enable the ADC. Then next step we have to enable the DMA. Next is DMA config. Okay. So in DMA config, what we have to do? We have to give the address. Okay. Wow. In this unsigned int of 32, you have to give the address. So going to undo it with ADC data register. So this is going to give me the value. Then So next is my RX data. And finally, I will give the size. Okay. So which is 1. So now we have configured the DMA. Then finally we have to start the DMA. Start the ADC, right? ADC of stop function. So this will tune on my ADC. Okay. Oh, we will compile this. So guys, this is how we will develop the code for ADC using a DMA, direct memory access. So in the next class, we are going to add the temperature sensor to it, and we will use the DMA to read the temperature sensor value and update store the value in the memory. And we will upload this. First, we will upload this code to my board, discovery board, and we will see the output. Then we will create. We will add the temperature sensor, and we will see the output for the temperature sensor also. So we will see it in the next class. So today class is over, guys. So thank you for listening. So we will meet in next class. Okay. So you are asked to change the pixel size. So guys, I will play this Q&A in the next class. So in next class I will explain this how we have created this code. In next class I will give an in the quick details about this code, and we will upload the code. Okay, then we will upload the code. Okay. So okay guys. So thank you. We will end this session. Okay.